we have looked at a number of methods for finding the roots of the equations. So these methods for finding the roots of the equations, we can also uh, apply in Excel, Matlab, and of course other methods. So let's see how we can find the roots of the equations in Excel. So in Excel, one of the first method is the trial and error method. Okay, trial and error method. Okay, so
We
suppose
cannot see Excel.
you cannot see Excel.
Yeah, we
Yeah,
only
we can
see.
see only PDF.
You can only see it on the PDF. Uh-huh. Yes, so in this PDF, can you see now Excel?
No.
No.
You should share the screen, not only the application.
Yeah, I'm sharing actually the screen only, but why is it happening like this? Okay, how about now?
Yeah, now we see the Excel.
Okay, so in Excel, we have the trial and error method, okay? So for example, in the trial and error method, if we want to find the root of the equation, of this equation, so we can find its root of the equation by the trial and error method. So for this, we will have one column as x, and the other column was for the function of x, value for the function of x. So it will be f into the function of x. So we can assume the value of x, any value may be 0, okay? And then we can calculate the value of the function of x. So it will be x minus, in this case, cosine of x. So it will be now -1. So we need to, by trial and error, we need to find the value. We need to find the value of x, function of x, so that it will become equal to 0. So maybe we can put different trials. So 0, maybe I can put 3. I can put 3 maybe. So now it from -1, the value has increased to 3.98. So from here we can see that as I increase from 0 to 3, the value has increased from -1 to 3. That means the value has increased from a negative value to the positive value. So in this case, in the next trial, I should put some lower value of x. So maybe I can put 1. So now it's 0.45. So now in this case, I can see that from -1 to 0.45. So the value should be again between 0 and 1. So maybe I can put 0.6. So it is now -0.225. So it means that now the value should be between -0.225 and 1. So in these two values, so 0.6 and 0.1, I can put 0.7. So now you can see that the value is very close to 0. So it is now between 1 and 0.7. Okay, so it should be 0.74 maybe. Yeah, now it has increased further. So but it is minus and then plus. At 0.7 it is minus. At 0.74 the value is plus. So it should be between these two values. So maybe it is 0.73. Yeah, so 0.73 is 0.01. So now I can see that it is between 0.74 and 0.73, right? So it should be 0.735. So in this way, you can perform the trial and error, and then as many number of digits you want to make it closer, then you can do it. So in this way, you can use the trial and error method, because trial and error method is just a trial and error method. You have to make a trial, and then you want to see how much is the error in visual terms. So closer, the smallest is the smaller is the error, better is your trial, and then in this way you can get an estimate of the root. Another method is the goal seek method in Excel. Okay, goal seek. So goal seek is a function in Excel, and then using that goal seek, we can also find the values. So for the goal seek, if I want to apply the same method for this, if we want to apply this method for this the same function f of x is equal to x minus cosine x. So what I can do is I can go to the data tab, okay, and in the data tab you will have this forecast tools, and in the forecast tool you will have what if analysis, and under the what if analysis you will have this goal seek function. So it is a very small simple function dialog. So in this case, the first value is to set the cell to value 0. So what I want in this case is that I want to set this cell, that is function value of the function of x, to 0, because I want to make this as 0. By changing this value of x, and then I have selected this value of x, and now I will click OK. So after some few milliseconds, we will see that the value in the function of x has now reduced to minus 3.8 into 10 to the power minus 5, which is very much close to 0. Corresponding to that, I have the value of x, which is 0.739062. So this is answer. This is an answer which is provided by the goal seek function. Okay, so this was one function in the Microsoft Excel. The other function is the solver add-in. Okay, so because it is an add-in, so it has to add into the Excel. It has to be added into the Excel if it is not already available. Okay, so this is more sophisticated than the goal seek, and it includes some more applications as well. So for example, if I want to apply this add-in function, so I have to apply this method by the solver add-in. So I have to click this solver over here on this right hand side, if you can see, under the analyze section of this ribbon. Under the analyze section of the ribbon, it will be under the data, and under the data it will be at the analyze section solver. If it is not available, so then what you have to do is you have to add in from the options. So you will go to the options, and from the options you will click add in over here, and in the add-in you will have in this manager you will have the Excel add-ins. In Excel add-ins you click go, and then from here then you will have to select the solver add-in over here. I already have selected, but if you cannot find it in your main Excel view, then you can add in from here. So you have to click solver add-in from here. So anyway, so when you apply it from the solver, then this type of dialog box will come, and it is very similar to the goal seek. So it will say that set the objective. In this case, our objective is this function x. We have to set this objective to a value of 0. So you have to select to a value of 0 by changing the variable. So the variables are over here. The variables are over here. So in this case, I have already selected these values, and then I will click solve. And here I will see that the solver found a solution, all constraints and potentially conditions and optimality conditions are satisfied. So the solution has been found. So the solution has been found over here, right? So now I will click OK. So, and then I will see that this is the solution which I got from the solver function Addin, and then this is the solution which I got from the goal seek. So here you can see that there is a difference between these values. Solver is providing us more accurate results because it's the value is now 2.4 into 10 to the power minus 4. It is more closer to 0 than this value. So with solver, we can sometime obtain more accurate results. Okay, so this was one example with solving. Another example with solving can be also useful because solver is a more sophisticated function. We can use more sophisticated example like solution of the nonlinear system of equations. So instead of one equation, we can use two equations. So such as in this case, the system of two equations. Okay, so in this equation, what we can do is, first we can input, in this case for the solver Addin, first we can assume the values of x and y, and then now there are two equations. One equation is u of xy, and the other equation is v. So we can first calculate the function u and then calculate the function y. And initially we can assume, say, maybe 0 and 0, these values, okay? And then what will be the function u? U will be equal to this x square plus x times y minus 10. So this will be the value, okay? X square plus x times y minus 10, okay? And then the value of y will be equal to, sorry, the value of u will be equal to, so this is not u, this is v. The value of v will be equal to y plus 3 times x times y square and minus 57. So I have input the value. So for it is obvious that for 0 the values are minus 10 and minus 57 for these functions. So since in this case I have to solve these two equations, so the values of x and y should be found in such a way, okay? We should find the values of x and y in such a way that u should be 0 and v should be 0. Okay, u should be 0 and v should be 0. But we want to solve it by the solver Addin. Okay, so in the solver Addin, we see that our the values of u and v are related with the objective only. So, but in this case, there is a restriction for the there is a restriction that we can only set an objective. We can only set one objective. But here we have two objectives. In this case, u and v are the two objectives. So we cannot set two objectives in this solver. So therefore, we will make some one adjustment. So what will be that adjustment? So that adjustment will be that. So for example, if the value of u will be very near to the 0 and if the value of v will be very near to the 0, so it can be both. It can be very near to the 0, but the value can be negative. It can be very near to the 0, but the value can be positive. Okay. So, but when we will take the square of those values, the values which are very near to the 0 and the square of these values. So the square of these negative values will be also positive. And the square of the value which is very near to the 0 will be also less than the original value. So for example, the square of 0.01 will be 0.001. Okay. So in this case, what we can do that we can take the sum of the squares, and if the sum of the square, because there will be no there will the squares will be both positive. So if the sum of the squares will be closer to 0, then that can provide us the better objective in this case. So what we can do is we can calculate the sum of squares. Okay, so our objective will be that the sum of the squares should be very close to 0. So that will be the square of u and plus the square of v. Okay, sum of the squares. So in this case, sum of the squares is 3349. Of course, it is not 0. So what we have to make it closer to 0 by changing the values of x and y. So for this, we can use the solver function. So solver add-in. So now I will set these values. So I will set the objective of this, and then I will this objective should be set as 0. So by changing the variable cells, so in this case the variable cells are x and y, and then I have adjacently put these variable cells. So by changing the variable cells, so objective was here set L12, okay, and to a value of 0 by changing the cells, which cells, x and y, okay, L and L7 and L8, okay, and then I want to change these two cells, and then initially I have put the values of 0 and 0 over here, and now I will click solve over here. But here I got an error. Solver could not find a feasible solution. Solver cannot find a point on which it can, on which all constraints are satisfied. So in this case, solver has failed to provide us the solution. So let's see what the solution the solver has provided. So solution the solver has provided is like the value of x is 3.1 into 10 to the power minus 5. The value of y is 56.5757. But by using these two values, the sum of the squares is 99. The value of u is minus 9. The value of v is 0. Okay. The value of v is closer, but the value of u is not closer. So this means that the solution which we have obtained is not correct. So the reason may be because our initial guesses may be not correct. Okay. So maybe instead of 0, 0, I can put a guesses of 1 and 1. Then see what happens. So, and now I apply the solver add-in. Okay. So the values are the same, and then I click solver. But in this case, you can see that it can say that the solver has found a solution. All constraints and optimality conditions are satisfied. So I click OK. And here I can see over that. If I put the value of, if the value of x is 2.0000541 and the value of y is 3.00041, then the value of u will be 0.000 this, v is this. So all these values are quite close to 0, and then this, since and therefore their sum of squares is also 0. So x, and so we have got an approximate results of x and y. The exact results are, in fact, we already know it, these are 2 and 3 because we have already solved these questions, but we have got the approximate results which are very much closer to 2 and 3 in this case. So by this we can see that the solver and the goal seek function sometimes may not work. So in those situations, so what we have to do is we may have to change our initial guess, and or even maybe you can also change the form of the equations which we are trying to evaluate. So in the in those situations, the solver may provide you some solutions. Okay, so do you have any question about this? Hello?
No. No question.
Okay. Okay, so then let's try the finding the solution of the equations on MATLAB. Okay, so we will be using the MATLAB to find the solution of the equations. So in MATLAB, there are several commands which can be used for finding the solution of the equation. So for example, if we have the equation such as, for example, if you want to find the solution of the equation, solve f of x, is equal to x minus cosine of x. Okay. So suppose if we want to, can you see what I am writing on MATLAB?
Yes.
You can see. So I have written it percent solve fx is equal to cosine of x. So this percent sign is just for the comment. So it is not a MATLAB command over here. It is just to show that what I want to do over here. So suppose if we want to find the solution for this equation fx is equal to x minus cosine x. So we can use a command in MATLAB, which is called as the fzero. Okay, fzero command. So fzero is a MATLAB function, inbuilt MATLAB function, and then we will first, if you want to use this fzero, so we'll first define the in what independent variable this function is. So for this, we will use a syntax which is called the anonymous representation of the function. This syntax uses the symbol @ okay, just like in the email address @ and then parenthesis, and then x. X is the independent variable. If the independent variable is say y, if the independent variable is say c, so you can use accordingly y, c, etc. But in this case, since our equation is in terms of the x, so I will use x over here. And then you will put a space, okay? You will put a space, and then in this case, you will put the equation. So x minus cosine of x. So this will be the equation. Okay. So this is the first argument for the fzero function. Next, we have to provide some guess. Okay. So in this case, maybe I can provide a guess of 0. Okay. So, and then I close it. And then the command is completed, and then I will enter it, and I will get the answer is equal to 0.7391. So, which is in fact the correct answer. Okay, which is in fact the correct answer. So, and let's try this to find the another equation. Before, if we want to find this in terms of the function, then if we want to, so we have got this answer 0.7391, but if we want to verify this answer, then I think what you can do is, I recall this command, I will recall this command, and then I will put equal to say maybe x, okay? Okay, I want to find this value in terms of x. So x will be equal to this, okay? Okay, so let me do the same equation in another way. Okay, so let me define this function of x as something like this. F is equal to this function f is equal to at x x minus cosine of x. Okay, so this is the function of x I have defined. Okay, now if I want to put if I want to evaluate this function for 0.7391, okay, so I will put f 0.7391, okay, and then I will hit enter, and then I will see that the answer it's some error. Okay, yeah, so because I made some mistake over here, okay, I will correct. It is cosine, cos cosine of x. Okay, and now I repeat the command f 0.7391. So what I can see is I get an answer of 2.488 into 10 to the power minus 5. So did you get what I am doing over here? I have verified this answer. Okay, I have verified the previously the answer which I have got 0.7391. I have input that answer into the equation. Okay, and then I got that the value of this function is 2.488 into 10 to the power minus 5, which is very close to 0. Okay, so in this case, the I can say that the answer which I have got from this f0 function, the solution, the root which I have got from this x0 function is correct. Okay, so let's do it one more example. So maybe I clear CLC. Okay, so this time now solve x to the power 10 minus 1. Okay, so if I have this equation, solve x to the power 10 minus 1, that is f of x is equal to 10 to the power and f of x is equal to 10 to the x to the power 10 minus 1. Okay, so in this case, what I can do is, first of all, I can define the function. Okay, so function is, I can say function of x. Okay, function of x is, or just some f is equal to at x, x to the power 10 minus 1. Okay, this is the function. So I put a semicolon over here, and then x to the power 10 minus 1 is the function. So now I want to solve this function, and the solution I want to place it in a variable which is called x. So x is equal to f0 f0, and now I can just put the name of the function. I don't need to put at x because I already have defined it. So f0 is for f, and now I need to provide an initial guess. So for the initial guess can also be in the form of a range of values. So the range of values can be provided by, say, in the form of in the form of a row vector as well. So for example, if I want to find its solution from 0 to 2, that means if I want to search the solution between the values 0 and 2, then I can put like this, okay, 0 to 2. So 0 to 2 is the range. So in this case, this function will only find the solution between 0, the values of x between 0 and 2, okay. And now I can click enter. And in this case, I have found the error that because I put f0 as incorrect. So it has suggested me to correct f0. So the spelling, there was spelling mistakes. So I put enter, and then I got the answer x is equal to 1 over there. So in fact, which is true, because for 1, if you will put, I will get the answer. Similarly, if you want to suggest for this another range, maybe in the negative range, f from 0 to -2, and because we also know that this x to the power 10 minus 1 has another solution at x is equal to -1. So in the range of 0 to -2, there should be one solution as well. So in this case, it has also found a solution of x is equal to -1. So as you can see that you can use this f0 function for any equation and within the specified range of values. Okay. Okay. So do you have any question about this f0 function?
No.
Okay. So next let's find the solution of the polynomials. Okay. Okay, solution of polynomials. So roots of polynomials. Okay, roots of polynomials. So suppose we have an equation, a polynomial equation like this. Can you see? f5 into x is equal to x power 5 minus 3.5 x power 4. We have this equation. Okay. Suppose we have this polynomial equation. Can you see it?
Yes.
Okay. So because it will take time to type this equation in this command window for the Matlab. So I have just shown it to you like this. So this polynomial so this polynomial equation we can solve by the fzero command as well. But there is a better function in Matlab other than the fzero, that is called as the roots function. So that roots function can be used for this polynomial. So first of all, there is a way for representing the polynomial in MATLAB. So for representing the polynomial in the MATLAB, we can just represent it with the form of a row vector. Like this. So for example, if the variable which we choose is a for representing that polynomial, so we can just write down the coefficients of the polynomial. So our coefficients was x to the power 5, its coefficient is 1, minus 3.5 x power 4, so minus 3.5, and plus 2.75 x cube plus 2.75. Plus 2.125 x square, 2.125 x square, and minus 3.875. So minus 3.875 x, and 1.25 was the last term. So if instead of representing the polynomial in MATLAB can be represented by its coefficients. So if you can write the coefficients of the polynomial in the form of a vector, okay, in the square brackets, so then we can represent that polynomial, and then we can perform some calculations on that polynomial. Okay, so in this way, I have represented this polynomial by this vector A. If I want to evaluate this polynomial, so for the value of x is equal to 1, so I will use polyval function, and polyval function will take the value the coefficients of the polynomial, which are a in this case, and the value of the independent variable x, so which is 1 in this case. So in this case, I have evaluated, if I will hit enter now, it will give me the answer of minus 0.25. Okay, it will give me the value of minus 0.25. So which will be the evaluation of the polynomial. That means if we have this polynomial in x power 5, x power 4, x power 3, 2, 1, etc. If you put the value of x is equal to 1, so we will get an answer of minus 0.25. So the polynomial can be evaluated this polyval command. So which polyval command then is using the specific structure for the polynomial. Similarly, the polynomial, the determinant of the polynomial can be found. Polyder, okay, polyder, and then we have this polynomial which is represented as vector A. In this case, the coefficients of the polynomial are represented by vector A. So if we will use polyder A, so it will be, it will give us the coefficients for the determinant of the matrix. So for example, in this case, the first value for the polynomial was x power 5. So for x power 5, the determinant is 5x power 4. So the coefficient will be 5. The next one was minus 3.5x power 4. So minus 3.5x power 4, 3.5 will be multiplied by 4, that will be 14. So it will be minus 14. So in this way, then we will get the determinant, the first derivative, we will find the first derivative of the polynomial, okay? So polyderivative. So first derivative of the polynomial, and these will be the coefficients. And similarly, you can find the second derivative of the polynomial by taking the derivative of it one more time. Okay. Suppose if we have a polynomial which is x squared plus 0.5x minus 0.5. So if we have another polynomial, okay, another polynomial, okay, if we have another polynomial with which is x squared plus 0.5x minus 0.5. So we can represent this polynomial by its coefficients as 1, 0.5, minus 0.5. Okay. So this is b. This b is now represented by this vector 1 minus 0.5 minus 0.5, and it represents the polynomial x squared plus 0.5x minus 0.5. Okay. So we can also perform the division of polynomials. So now I have the division. I have this the first polynomial in 5th degree as a, and the second polynomial in 2nd degree as b. So I can divide the polynomial a, the first polynomial by the second polynomial, and that division will result into two values: the quotient, which we can represent by d, and then the remainder, which we can represent by e. And the function which is used is called as the deconv, deconv. Okay, deconv. And then in this case, I will take the first polynomial as a and the second polynomial as b. So this is the command. Okay, if I input this command, this command shows that I am dividing the first polynomial by the second polynomial, which I have already defined over here, a and b, and then their result will be the quotient and the remainder, the quotient and the remainder. So in this case, incidentally, the remainder will be 0 because this second polynomial can fully divide that polynomial. Okay, 1 minus 4, 5.25 minus 2.5. So the resulting polynomial will be x cubed minus 4x squared plus 5.25x minus 2.5. Okay. Okay, and so this is how you divide the one polynomial with the other. And lastly, if I want to find the roots of the polynomial, so I can simply use the command roots. Okay, so this roots command can be only used for the polynomials. For normal non-linear equations, polynomial is a linear equation because it has the linear coefficients. For non-linear equations involving sine x, cosine x, etc., exponential function, we will use the fzero command. But for this polynomial, so for now, if we have this polynomial a, polynomial which is represented by a, and then we can find its roots by like this. So let's say the roots are, we can represent in a variable named r. Okay, and if I hit enter, and then I will get the roots. So these will be the roots. Okay, these will be the root. So you see that the original polynomial was x cubed minus 3.5 x4 plus 2.75. So it should have 5 roots, and this roots command has found all those 5 roots. And out of these 5 roots, how many roots are real and how many roots are complex?
3 are real and 2 are complex.
Yes, yes. 3 are real because although the format is all complex, but 0 I is actually 0. So it is, this is first root is real root is 2, another real root is minus 1, and the third real root is plus 0.5. And then the two complex roots are 1 plus 0.5i and 1 minus 0.5i. Okay. Similarly, we can multiply two polynomials. So for this, we use the command conv, conv to multiply two polynomials. So earlier, our smaller polynomial was d. Okay, the second order, the remainder polynomial we did not find actually. Yeah, so in the when the division was performed. So maybe we can multiply d with say a, and then let's see what we get the answer. So we get the answer like in this, because we were multiplying the 5th order polynomial with the 2nd order polynomial, so we will get a 7th order polynomial. So it will be 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, and 8. Yes, because A was 5th order and D was 3rd order. Yes, D was 3rd order. So it should be 8th order polynomial. So this was something about the polynomials and how we find the polynomials, the roots by the polynomial equations. Okay, so that was the topic for the roots of the polynomials. There is another software which is MathCAD, but I am not going through this software. So we will only be using the Matlab and Excel over here. Okay, next is the next topic, so which we will start. This topic is the Gauss elimination method, which is chapter number 9. In fact, most of this topic we have already covered in our linear algebra class in the last semester. So this will be relatively easy, and then I think I can go through this topic rather quickly. Okay, so I think now it's almost the time for the end of the class as well. Okay, so yeah, one more thing. So yeah, so you can see that in the in your Moodle, you have now the practice quiz 4 and practice quiz 3 available. Similarly, the sample problems for the bracketing method and the sample problems for the open methods are also available. And later on, I will also add the practice quiz for the polynomial roots of the polynomial and the sample problems for the roots of the polynomial as well. Okay. And your quiz will be on next Friday. Okay. Yeah, that means the coming Friday, 4 days later. So quiz number 2 will be from the bracketing method and the open methods. And in tomorrow's lab class, I will demonstrate you how we can employ the bracketing method, the false position methods, and possibly other methods into the Matlab. So in Matlab, you can see that it's very easy to perform the to find the roots of the equations by the fzero function and as well as the roots function. However, how the mechanism works in those methods, for this we need to do some to write some scripts in Matlab to show how the solutions are found out. So that will be the topic of the lab tomorrow. Okay. So do you have any question?
No.